Most and reverential pranams at the divine lotus feet of our beloved one. Most revered Dr. Kameshwar Rao, sir, respected members of teaching fraternity, loving Sairam to all of you. We are extremely happy to welcome and introduce Dr. Kameshwar Rao, sir. Sir is featured associate professor, former master trainer of NCRT, closely associated with Sri Sathya Sai Vidyavahini programs. Sir is a member of preparing NCRT books. Sir conducted a number of workshops for teachers of Kendriya Vidyalaya. Even in other countries, Sir organized training programs for teachers. Dr. Kameshwar Rao, sir, is a member of National Focus Group on Teaching of Mathematics, a teacher of vast experience in teaching and experience in training the teachers and training the master. This is a great blessing from our beloved Bhagavan to get such a renowned trainer for our sake. And as we know, Swami gives always the best. And this is another example for that. On behalf of Sri Sathya Sai Seva organization, South Zone, and on behalf of all the teacher participants from the different schools who are in this call, we welcome you, sir, to this session. And once again, we express our deep gratitude to all the teachers and Sir Dr. Kameshwar Rao, sir, for enabling us for conducting, for arranging this session. Once again, welcome you, sir, to this session. I request you, sir, to address the teachers of this session. Sairam, thank you. Dr. Kameshwar Rao, sir.
Sairam. For the last 1 month, I have been waiting for this opportunity. Finally, Swami has graced for this occasion. Normally, I engage and enjoy the offline training, offline interactions. But this is online. I don't know how far I can put across my experience. Let me try. My talk would be centered around the pedagogy of mathematics, learning of mathematics, a mathematics teacher, nature of mathematics. These are some of the things I'll be touching upon. Time permitting, I don't know how far it may lead. The topic I was given to speak is learning mathematics joyfully. In fact, I would say the joy of learning mathematics. There is such a beautiful joy that you cannot compare with any other field of knowledge. But then, of late, parents, children, individuals look at mathematics as something very not interesting, dull, and one cannot see anything in mathematics. Well, let's see. Let's see what makes them feel this. Basically, people want to see things. When they want to see things, they want to see with their own eye and with their own understanding. So what they miss is the beauty of mathematics existing in it. That is what I will try to unfold in some of the aspects. Mathematics is said to be a network of ideas created by human mind. So when we say it's a network of ideas, it is totally abstract in nature. It's abstract in nature doesn't mean that no one can see it. In fact, it is we who can see it and visualize what is there in it. And some say it's a study of patterns. The beauty lies in the patterns. Some see beauty in designs, symmetry, but there is beauty in many things. You name it, there is beauty in it. And that beauty is mathematical, totally mathematical. So, to see that beauty, to experience it, one has to look at things as simple as possible. For me, mathematics is a journey. It's a journey. There is no end to it. You start right from the day you open your eyes and you continue. And you see everywhere mathematics. Everywhere. Formally, in the schools, we begin by saying counting. But to enjoy even this counting, just not counting, but an activity designed to see certain patterns, to set certain patterns. So to understand even the counting, a child sees around lots of objects. A child sees objects which look triangular, which look round, which look rectangular, which look squares. Of these shapes that I mentioned, one of them, I said square. Square is just not a geometrical shape. Square also is associated with numbers. Rectangle is also associated with numbers. So while counting itself, if a child doesn't know why he or she has to count that, child would not love doing it. So, as a parent, instead of dictating them the number names, provide a situation, even before counting, whether a child can distinguish between objects. Child doesn't have to count, doesn't have to measure, just by look of it, should be able to grasp the idea of big and small, long and short. Given objects, must be able to arrange them in order of their height or in order of their size. No, these are fundamentals. These are necessary. Child must be able to do this, and child takes it as a challenge to do it. And children always love challenges, and we should provide them with that instead of directly asking them to say 1, 2, 3. As I said, mathematics is abstract. Abstraction should not begin at home. The understanding of mathematics should begin with concrete examples, concrete objects, and then a child would feel the need to compare them. When the comparison comes, then there is a need to count. So counting is fundamental, but some prerequisites are needed for understanding and enjoying this counting. So, as child starts counting the objects, in the school, we simply say, just say 1, 2, 3, and so on. But then, if we engage them with objects in counting, like you put 1, take an object. Maybe I will take a small bead. I will take a small bead. I'll put it. I will take for 2, I will take 2 beads. And 2 beads is 1 and 1 together. And when it comes to 3, let me put the 3rd bead between them. Now it gives a shape. It will give a shape like a triangle. Later on in the academic life, a child will see 3 as a triangular number. So in the counting itself, begin by, when you put 4 of them, put 4 of them like this. They make a square. They make a square. For 5, 6, 7, 8, you can clearly see when there are certain numbers, you can create rectangular shapes. So straight after 1, it is 4, and then you get it 9 again, you get a square. So a child would know, oh, 9 is a square. 9 objects are needed to make a square. And here the square is of 3 pebbles or 3 beads, 3 objects on each side. So it becomes a 3 square. And now, just don't move forward. Just see. For 1 to make another square 4, you have added 3. And for 4 to make it 9, you added 5. So from 1, you have added 3. Then you have added 5. And therefore, what can you get? Or how many bits you have to add to get the next square? You can see the pattern. 1, 3, 5, and next one would be 7. So when you add 7 to 9, you get 16, and you get another square. Just don't leave them by saying just count. While counting, associate with shapes, designs. And if you go slightly deeper into it, you can see child would be able to distinguish between where rectangle can be constructed, where it cannot be constructed. And later on in their journey, they will find out how composite numbers and prime numbers can be easily distinguished by these shapes. So just counting for the namesake is just a rote memorization. Mathematics is not a spectator sport. Mathematics is to be enjoyed by playing it. So children, they have to learn by doing it, not by listening to or observing. When they do it, they understand. They feel the propriety of the art because they have done it. So generally, as a teacher, I have never answered students' questions. Never. If they come to me with a problem, I go through the problem and say, oh, that problem is for you, not for me. Your problem is your problem. It's not mine. Even my children, when they used to come and ask me problems, I never answered them. I used to question them with few more questions. Thereby, they used to understand, oh, this is it. I will give you just one example of a situation. What happened? My eldest daughter, when she was in standard 5, she came to me with a problem that read, the population of Patna city was 4,08,964 in the year 1961. In the year 1971, it is 8,407,000. What is the increase in population? Exactly, this is what she asked. And she asked me, if you tell me whether to add or subtract, and which one to be added or which one to be subtracted, there are numbers in lakhs, there are numbers in hundreds. 1961, 1971, what is it? I don't know. I don't think there is a multiplication. It looks there is an addition or subtraction. I said, my dear, you have to tackle with this. I can give you one example of similar question. In the year 1988, in our house, we were only 2, your mother and me. By 1998, we are 5. What is the increase in population? On hearing this, she immediately jumped and said, no, I don't require your help. I understand now what I can do. So, teacher must be willing to deny answering children's questions. The questions are meant for them. Teacher should not move forward to do it. I sometimes in the training programs, I say, when a student comes to a teacher with a gulab jamun and asks, "Sir, I have not eaten this any time. Please eat and tell me what is its taste." Teacher would love to eat it because he knows its taste. He eats it and says, "Gulab jamun is sweet." So in the exam, when student was asked, "What is the taste of gulab jamun?" Student would write, "Gulab jamun is sweet as told by my teacher." On the other hand, if the teacher says, "No, this gulab jamun is not for me, it is for you. You need to eat." If the student says, "No, I have never eaten such a thing," no, eat it for first time. When student eats, you put the question again, "What is the taste of gulab jamun?" The student would happily answer, "Gulab jamun is very sweet. I would love to eat it whenever I get a chance to." So don't deprive the children of the thrill or the taste of solving a mathematics problem. Problems are meant for them. Teachers are not to snatch away that. If some problems children cannot do, and you think it's impossible for them to do, it's not worth learning for them. It's not worth learning for them. We build on what is called the constructivist approach, where they are, and from there we build on, not from anywhere. And children are always in a class, not with a blank slate. They have abilities. They can connect. So the teacher must focus not on teaching, focus on learning of the students. Focus must be what is learned. That is more important than I covered this syllabus, I'm left with this, and all that. That doesn't help children to learn mathematics. That may help them to solve some problems by imitating what procedure we have set. So we want children to enjoy solving their problems. So we don't say, "Swami, please solve my problems." No, Swami never encourages people to come and ask to solve problems. We pray Swami to make us competent to face problems. And in a classroom, right answers are less important than wrong answers. If children commit mistakes, there is something for them to learn. If a child does a problem correctly, his brain is static. When a child faces problem, commits mistake, knows it's not correct, then the mind tries to grow, try to generate ideas. Maybe another idea, next idea is also wrong, but still he will know it is wrong. It is not working. So we say, I was talking about that counting and physical objects. concrete relationship. There, I have mentioned, while counting itself, if they just don't count, but then place them also in a particular order, in a particular shape, they learn. This kind of learning is what we call deep learning. Deep learning means making connections. We want children to make connections when they learn. If simply learn for the sake of learning, it becomes rote. Once they make connections, they are making use of it. As they make use of it, the connection string increases and they can see various connections they can connect. That was a simple example I have taken for counting. So we want children to extend their boundaries of understanding. So to extend the boundaries of understanding, teacher has to provide a context. So teacher as a facilitator must provide a context. Context does not mean anything. We will talk about hypothetical things. Should be able to create a context which is familiar to the children, which is familiar to their surroundings. And the language the teacher uses is accessible to the children. That is very important. Above all, that context must be challenging. Then only the mind attempts to think. And when they think, when they go to the edge of understanding, learning will begin to take place. So, deep learning, making connections, must begin right from the childhood. Right from the childhood. Rote learning should be avoided at any cost. At any cost. And I will see, mathematics is also a study of patterns. Children can see patterns faster than adults can. I will give you an example of patterns. I will give you one situation where I had encountered and realized how foolish I was in thinking that multiplication tables must be by hearted. I thought for a long time that children must by heart multiplication tables because I used to by heart my multiplication tables when I was in school. The first thing we used to go and do in the class was to recite multiplication tables. We never knew why we were reciting. Only reason is the teacher will beat us. Otherwise. But we have not enjoyed how, why, and where it is used. So, sometime in 1999, a 4-year child came to me and asked me, in a match in Sharjah, in a cricket match in Sharjah. Sachin Tendulkar hit 15 boundaries and 5 sixes. What is the total score? So I asked the child, do you know multiplication? He said, no, I don't know what it is. Then what do you know? That I know counting. I know addition, I can count. So you haven't heard of multiplication tables? He said, no, I'm in lower KG and I don't know. I haven't heard of this multiplication table. I have seen only 2 tables. One is the dining table, other one is my father's study table. Only these 2 tables I have seen. Multiplication table I have not seen. Then I said, okay, I will teach you multiplication table. Come in the evening. He said, I will come exactly at 6 o'clock. You will teach me multiplication tables. You will show me what is that multiplication table. How does it look like? And they left. That was in the morning. And throughout the day, I was thinking, this child has not gone to school to study multiplication, addition, subtraction. These things he has not done. How am I going to introduce multiplication table to him? My wife said, why do you worry? For our daughters, you had made them generate multiplication table with the help of tamarind seeds. And I have saved these tamarind seeds I have with me, and you can use them. So I said, okay, I will do that. So evening at exactly 6 o'clock, he arrived and said, show me the multiplication tables. My wife was trying to see how I'm going to demonstrate this time. My daughters were trying to see so that they can recall how they generated multiplication tables on their own. So this boy came and said, you said you will show me multiplication table, but you are holding tamarind seeds. I said, don't worry, you can see the tables also. So I had taken 2 tamarind seeds and put one near the other and asked him to count. He counted, this is 1, this is 1. I said, how many ones are there? He said, there are 2 ones. Then I said, okay, 2 ones, so we write it like this. We write it like this, and I said 2 multiplied by 1 is equal to 2. Then I put 2 tamarind seeds, 1 each by the side of where I have put 1, and asked him to count. He counted, oh, there are 2 twos, separately 2 twos. I said, how many are there? He said 4. Okay, so we write it as 2 times 2 equal to 4. Then 2 multiplied by 3 and so on, we developed up to 2 tenths. Then adding just 1 to each of them, we developed multiplication table 3. Then when my daughters went up to 4 by placing those standard seeds. And one daughter was writing 2 ones, 2, 2 twos, 4, and 3 ones, 3, and so on. Now, this boy was keenly observing what is written. And he asked, "Still, you have not shown the mathematics table to me." I said, "What I am writing, the 2, 4, 6, 8, 3, 6, 9, these are all multiplication tables." He said, "Oh, these are multiplication tables. Now I will tell you, you just write. I don't want these standard seeds." And he went on dictating me multiplication table 5, 6, 7, 8, 9, 10. And when he came to 11, I said, "Stop." My daughters and wife were surprised. How this boy who didn't know how to multiply is able to just recite this. I asked him, "You were probably adding. You're adding 2 in the first table, you're adding 3 in the second." He said, "No, I'm not adding." Then I said, "Maybe you are multiplying it." He said, "No, I'm not multiplying. I don't know what is multiplication. You only put that cross and said 2 multiplied by 3 is 2 times 3, and I didn't know this." Then how did you do this? He said, "You look at it. In the 2 table, you are writing the next one by skipping the next number. 2, you skip 3, you write 4. You skip 5, you write 6, and so on. And for times table 3, you skip 2 and go on writing. And for 4, you skip the next 3. For 4, 5, 6, 7, you skip, next is 8. And the boy was very good at counting. He mastered counting. So I said, "How is this?" He said, "While counting, I learned what is called skip counting. Skip by 1. I skip by 1, then I can see this multiplication table, which you call is of 2. If I skip 2, I get 3, and so on." In fact, there is a pattern. Let us allow children to look at the beauty of mathematics. Grab the beauty, see the beauty, experience the beauty. Don't torture them by asking them to by heart. As long as they don't enjoy learning it, it's not learning for them. It is just time pass. So we want them to actively involve, not just by physical manipulation, but mentally making constructs, mental constructs. And normally in the tables, what you write, 2 below that, 4, 6, and so on. And you call it multiplication table 2. Later, when you introduce sequences, you write one after the other, 2, 4, 6, so on, and you say it's arithmetic sequence. When you make them generate this table, why don't we ask them to write in a sequence? Let them see the multiplication tables are all arithmetic sequences. They don't have to wait till class 8 or 9 to understand what is an arithmetic sequence. They know what is an arithmetic sequence now itself. There were lots of questions connected with these sequences and all. When this child moved into standard 3, I had encountered his ideas and were really thrilled to understand how children can think like that. So that is an experience I wanted to uh, share with you all. Now, the class for mathematics teacher should always start with a question. Question in the form of a context. The context must be challenging. It must be challenging. It must be teasing also. I'll just give an example. Um, I have a container. It can contain any amount of water, say around 1 liter it can contain. This can measure 500 ml. This can measure up to 800 ml. I don't have any other containers. This has full of water. This is empty. This is empty. This can hold 800 ml. This can hold 500 ml. I want exactly 600 ml of water using them. This is not calibrated. This is also not calibrated. I know only this is full 800. This is 500. This is also not calibrated. This can contain only 1 liter of water. I don't have any other utensil to do the process. I want exactly 600 ml of water. Now, to solve any mathematical problem, one has to study deep, see the connections. One has to look at the relationship between the numbers 500 and 800. How I can get 600 from using them? I cannot just use this to get 600. I cannot use it to get 600. This cannot hold more than 500. This can hold 500. It can hold 600. It can hold up to 800. There is enough water here. Now, this is a situation. If teacher tries to solve it, teacher is snatching away the thrill of solving it by children. Teacher should not be an answer finder. Teacher must be willing to deny the answer. Then only learning will take place. As the NEP says, India must be a knowledge hub. Knowledge hub does not mean that we collect knowledge and keep it with us. and sell it. No. We want to create knowledge. Knowledge must be created. And this creation should begin right from the school, right straight from the classroom. If I in fact don't like the word teach. If the teacher enters to teach, it becomes only one way. If teacher can inspire children to learn, if a teacher can inspire the future students to construct knowledge in their own way, there are multiple ways of reaching the goal. Children should explore all that. So if a teacher solves a problem on the blackboard, all the children copy it down and think that is the process. The moment child asks a teacher to solve a problem, no one is able to do it. If teacher pauses and says, no, it's meant for you, then only they will start thinking about it. So my advice to teachers is, please don't solve the problems given in the exercises in the class. They are not meant for you teachers. They are meant for the children. If you are picking up some problem somewhere from the exercise and doing it, you are simply snatching away the thrill. Children can commit mistakes. Even we can commit mistakes. We do commit mistakes. Even now, I do commit mistakes. I do. I admit. But when they commit mistake, their brains are very active. They become very receptive. They try to entertain another idea. So what is very important for the teacher when he comes across a wrong answer is try to find out what is wrong in it. Is the logic the child using wrong? Is there a calculation mistake? Mathematics, one of its nature is, it is logical. Basically, it is logical in nature. Mathematical logic is different from the common sense logic. It differs. Logic in mathematics is different from logic in the market. If you go to a vegetable shop and ask him what is the price of brinjal, he would say 30 rupees half kg. And if you pause a little, would say 50 rupees per kg. Now, if half kg is 30 rupees, how 1 kg will be 50 rupees? Will you say that no, half kg 30 rupees? No, my mathematics teacher told me 30 multiplied by 2 is 60, so you have to take 60. You'll be a fool. So, market logic is different. Common sense dictionary is different from mathematical dictionary. So, these are certain things the teachers and students must know. One of the natures of mathematics besides logical is it is highly structured. There is a structure because it is a human creation. There is a structure in it. In the structure, we begin with undefined terms. Then we define certain terms. Then we have postulates. Then we'll have theorems, and so on. And finally, what you call a proof. The word proof is there only in mathematics. You don't find proof in physics. In other branches of knowledge, they have evidence. They call it evidence. They verify. If someone has to prove something in physics, he or she has to convert their problem into a mathematical problem and then leave the physical aspects of that and then prove. And that is why they say physics became science only after the invention of calculus. Before that, they were only thinking it is natural philosophy. So natural philosophy became physics only after the invention of calculus, where they proved. Therefore, the fundamental principle here is mathematics is highly structured. Certain properties we establish, they will hold good anywhere. When you are talking about a triangle, the sum of the angles on a plane of a triangle is 180 degrees. You draw any kind of triangle, any triangle, anywhere, you will find it is 180 because it is proved. You cannot say that, no, I have a triangle where sum of the angles is less than 180 or more than 180. Then you have not drawn the triangle on a plane. Now, that is the beauty of mathematics. If something is mathematically established, now it is guaranteed. Other things, they have a warranty, but this is a guarantee. Now, that is the beauty of mathematics. Always, a mathematician's point of view is slightly different from others. I will tell you an incident. There was a book by Simon Singh, who wrote a beautiful book on Fermat's enigma, the Fermat's last theorem, about how for several years it was unsolved, unproved, not disproved also, but then Andrew Wiles proved it. In his book, he tells how mathematicians have their point of view. 3 people were traveling in a train in Scotland. One of them, a mathematician, one physicist, one astronomer. So the astronomer opened the window and saw and said, "Oh, all the cows in Scotland are black." Then physicist opened and said, looked at and said, "Oh, some cows in Scotland are black." The mathematician, one says all are black, and he says some are black. He looked through the window and said, there is a field in which there exists a cow. which is black, at least on one side. See the precision with which his answer. So one of the natures of mathematics is to be precise. To be precise. No finite number of examples can generalize in mathematics. No finite number of examples. That is the beauty of mathematics. There are always exceptions. Now, children must be allowed to think simple and deep. I will quote a simple problem. I gave this problem in class 9, and then they immediately noted, and then all started doing it, and finally they solved it. The problem was very simple. The problem I stated was, on a Republic Day in school, 100 students attended the function. 100 students attended the function. Some came in time, some came late. But at the end of the function, chocolates were given. How many students were all there? There were 100 students. What the principal did was, all those who came on time were given 4 chocolates each, and all those who came late were given 2 chocolates each. That's the way principal thought to punish them. And he found there were exactly 350 chocolates which were spent. Every latecomer got 2, everyone who came on time got 4. Now the question is, how many students came late? And thereby, how many came on time? The class 9 students, all of them started beginning by saying, suppose, in mathematics, the teacher would always begin by saying, suppose. We suppose always. We suppose something, and we call it X. If there are another thing also to be supposed, we call it Y. Now, that is the style. So they started, let the number of students who came on time X and who came late Y, and therefore X plus Y is equal to 100. So that is the first equation, because they think once the equations are made, they can be solved. So the next, because X came on time, so 4 times X, 4X. Y came late, so 2Y. So 4X plus 2Y is equal to 350. So we have 2 equations in 2 unknowns, and therefore it can be solved. Now, first you have to make correct equations, then you have to solve it, and in the process you have to solve it correctly. Lots of addition, subtraction, multiplication, division are involved here. And they've done it. Most of them did it. The same question I gave in a class 4 class, standard 4 class. I posed this problem. I was on an individual, arrangement class. When some teachers are absent, I was teaching at higher classes. I was asked to look after that class for a while. So I posed them because just then only I posed this problem to class 9. I came here. I posed this. Within 5 minutes, 2 students came with the right answer. I was stunned. I thought they have guessed. And when I asked one of them, how did you get it? You have not calculated anything? And it is of a class 9 question. He said, no, sir, there is. It's so simple a problem. I said, how? How is it simple? Sir, those who come on time, 4 chocolates. Those who came on late got 2 chocolates. So the teacher, suppose, gives 2 chocolates each to all of them. So 200 chocolates are done. Because everyone will get minimum 2 chocolates. And the remaining 150 who will get? Those who came on time. There are 150, so 2 each, so 75. So 75 came on time and 25 came late. Where one has to look at things simpler, knowing mathematics should not prevent you from looking at things simpler. Then I asked the second boy, did you think like that? He said, no, I thought differently. I said, how did you think? How did you get that answer? He said, suppose I give 4 chocolates to each. I am falling short of 50 chocolates. 50 chocolate means 25 students will not get 2 chocolates each. Therefore, 25 came late. See how that is the beauty of mathematics. So my advice for the teachers is, please don't solve children's problems. The problems are meant for them. They need to solve. See, swimming cannot be learned by sitting at the bank. They have to get into water. Then only they will learn. So please don't dictate any answer or a process in the class. Let children explore. If you get a chance to meet the parents, do advise them not to help children do certain things instead of their doing themselves. Parents helping them with their homework, that doesn't help the child. It doesn't help the cause. We want knowledge to be created. Once the child does it on its own, it is hers. Otherwise, the child has to memorize, and if he forgets, he will not score marks. And marks are the criteria that we assess, which is very bad. We have to assess the learning, not their performance. When they are sitting in an examination for mathematics, different children come from different social background, socio-economic background, socio-academic background. How do you expect all of them to be at the same time, same level? When you enter a class, you don't get all the children born on the same date. Definitely not. So some born earlier have a greater start. Among them, whosoever was born later, but then got the exposure, could also do very well. So when the teacher enters the class, should not look at all of them as equals. All of them are potential learners. They're all potential learners. We expect them to learn, and we expect them to construct knowledge.
Sir, Sairam sir, many teachers have raised their hands. Is it possible to have a discussion, sir?
Yes.
Because many of them have raised their hand. If you would like to have a discussion, I think because 1 hour session is over now, half an hour we can have for discussion.
Okay, sure.
And it is very difficult to get sir again and again, but sir has got some topics for us, which will be coming in the next month. I request the teachers who have raised their hands, you can come forward with your query so that sir will be answering that. Sairam, thank you.
Sir.
Sairam, Sairam.
Sairam. Yes, I can hear you. Please go on. Hello? I think you are mute.
Sairam, please come with your question. Please come with your queries, please.
Sairam, please you can ask.
Sai Teja, please permit all the teachers to unmute, please. Sai Teja.
I unmuted, sir. They can unmute themselves.
Please come forward with your question.
I can't hear. I think
Please, is there any difficulty for you to unmute? Sai Teja, please check.
Yes, sir. I removed this, sir. I given
Okay, very
permission. Anyone can do.
Very good.
Yes.
Teachers, please come forward with your questions. As our beloved Swami says, time waste is life waste. Please don't waste time. If you have got any queries to be answered by sir, please come forward.
is there any technical snag? I'm not able to hear.
I request any teacher to unmute. Just try unmute.
And speak.
Sairam, sir.
Yes,
Sairam.
yes.
Okay.
Yes, please. Yes, please.
Sir, is it possible for higher classes, if we allow them to solve or find out the answer, many of the students are wasting time. So for 10th standard students, I think they have to face a board exam. So they are wasting time at that time, I think. So is it possible for higher classes, sir?
Yeah, why not? Why not? See, basic thing is when a topic is introduced, before going into the class, the teacher has to think why a child should learn this. Can it be related with day-to-day life? If it cannot be related to day-to-day life, child would not know why he or she should learn that. So if the teacher introduces them with a context familiar to the child, student will understand, student can construct the solution. Teacher should not be answer finders. Child should not be also answer finder. Child should be a solution maker. I gave the example of my daughter. She came with such a big problem. I gave her a simple problem. She understood. Now, I will just give you another example here. Look at this. This is 8 by 8 square. 8 by 8 square. If I ask you, how many squares are in this? What is your answer? What is your answer? You will simply say 64. But understanding the question is very important. My question was, this is 8 by 8.
Sairam, sir.
This is 8 by 8. If I ask you how many squares are there, it is not just 64. There are so many squares. The bigger one is a square. You have 2 unit squares are there, 3 unit squares are there. There are so many squares. Now,
Sairam?
if yes, if the
Sorry for
question
the
is,
disturbance. Shall we apply any formula for that? N into n plus 1 into 2n plus 1?
No, absolutely no. Absolutely no. See, one principle is when a problem looks big, when a problem looks big, reduce it to a smaller one and increase the magnitude of difficulty or the size. There is a pattern hidden in that. So whenever one finds a bigger problem, should find a simpler problem and build on that. If you take just the square, main square, and now divide it into 4 parts, how many squares do you get? You have 5 squares. Now make it 3 by 3. The same thing, you make 3 by 3. You have, there are, the bigger one square is there. There are 2 square, 4 small squares, and 3 square, 9 small squares are there. So first it was 1 square, it became 4 squares. So there is an increment of 3 here. And then it became 9. It became plus 5. If you recall, while counting, I was mentioning about how you count associate with the designs. And you see the beauty hidden in it. Therefore, the total number of squares in that 8 by 8 chessboard, call it chessboard, is 1 square plus 2 square plus 3 square up to 8 square. You enjoy doing it, you involve. Once you use formula means you are outsourcing, you are just outsourcing the process. You don't enjoy. So make the big problem look small. Okay? If the problem is not familiar, see what of that is familiar to you. No, children must be trained to go through this. Children must be trained how to solve. See, understanding the problem is most important. If they don't understand the problem, if they try to go to solve it, it will be a futile exercise. So let them try to connect with whatever they understand and can extend.
Sairam sir, Kameshwar Rao sir.
I think some internet
Right,
problem.
what happened?
I think some internet problem from Kameshwar Rao, sir.
Oh, he left.
Yes.
Just wait for 1 minute. Satyada, you take care. I will call sir.
Yes, sir. Yes, sir.
Sairam, sir will be joining now. The connectivity problem. He is joining through the mobile. It is a connectivity problem for sir. Just wait for 2 minutes and we will see. Sairam to all of you. We take this opportunity to thank you all for your presence in this call. We'll be sharing the video of the session within 1 or 2 days. And Dr. Kameshwar sir will be completing this in the next session. Yes, sir. Sir joined. We'll wait for that. Sairam, sir.
Can you hear me now?
Yes, sir. Yes, sir. Audible, sir.
Oh, okay. I'm connecting with the mobile. There is some problem there. The power went off there.
Yes, sir.
Okay. So that's what I was trying to say. Please don't demonstrate examples so that they will imitate that. They may imitate, recall, and get marks, but learning will not take place. Learning will not take place. So if you think that you have to do it and they have to copy and imitate that process, that they will not enjoy doing it. Maybe for marks, but not for understanding, not for using it further. So before getting into the class, try to find out why this topic must be dealt, not because it is in the syllabus, but how it is connected with day-to-day life. In fact, all the problems in algebra must be done, must be brought with word problems. Word problems. Quadratic equations. Don't begin by quadratic equation. Start with a day-to-day life problem and then convert it into a quadratic equation. Then it gives meaning. Simply solving a quadratic equation doesn't make any sense. If you connect with day-to-day life problems, then only it will make sense. And always accept child's ideas. And if a child commits mistake, please don't say it is wrong. Please try to find out how, as a facilitator, you can make the child contradict herself or himself. Can you give a connecting situation where the child, whatever child has got as answer, can contradict himself? Or the logic one is using is contradicted? Instead of saying you are wrong, if a child feels he or she has committed a mistake, realizes the mistake, so connecting the logic is more important than saying what is right. And saying it wrong is always not correct. And you may feel that in class, some of the students are very good, they are doing it very fast and others are not doing. If a student does it very fast, ask the child, can you do it differently? Can you do it differently? Can you make, can you construct a problem of similar type? No, that is how we have to engage them. Yes. Hello?
Yes, Sairam, sir.
Any other query?
If there is any other question, please ask.
Namaste, sir.
Namaste.
Sir, I found that language is always a bar while teaching mathematics. I mean, for the children to understand.
That is why the problem must be with word problems, not hypothetical x square plus 2x plus 3 equal to 0. No. Always find out how you come there. How you come there. So that is important. Maybe you may say that in the book they have given it like this, so we have to go like that. No, it's not like that. Now the next, I think, if you go through the class 6 book that which has come out now, it is all different. It's totally different. It's not algorithm driven. It is knowledge driven.
Okay, sir.
See,
Thank you, sir.
learning is the process of creating knowledge. Okay? So children have to create their own knowledge, not to imitate, not to take from you. You are not giver and they are not takers. You are simply a facilitator for them to create.
Thank you, sir. Thank you, sir.
Anyone else?
Sairam, anybody with any queries more? Because there are only 3 minutes more to 9. Sir, with your permission, we will conclude today's session, sir.
Okay. Okay. I think we
So
can.
we take this opportunity to thank and express our, not actually thank, deep gratitude to Dr. Kameshwar Rao. And extremely happy that because so simply Swat sir was explaining, as he said, told us everything should be made simple and common examples. Because I don't know much about mathematics because I studied only up to 10th mathematics. And it was a very difficult subject for me. And I didn't like mathematics, but sir, I started liking mathematics after hearing your class. Thank you so much, sir. Thank you so much on behalf of the organization and all the participants. And we thank all sisters and brothers who joined for this meeting. And I pray to Bhagavan to bless all of us, and especially Dr. Kameshwar Rao, sir, because such a beautiful session in the most simple term, the most difficult subject as far as I'm concerned. Thank you, sir. Thank you so much. And Bhagavan, grace will be always with you. And we thank all the participants also. Yes, any question, please?
Sairam, Sairam. Thank you, Sairam.
Thank you, sir. Sairam.
Sairam, sir, if it is possible, if you can have offline, then only the interactions can be lively.
Yes, sir. We will do that. We will do that. We will do
Otherwise,
that. We will try that.
Otherwise, see, I cannot show anything here, and then the thrill is lost.
Yes, sir. Especially for mathematics, it's not possible,
Yeah.
sir. We will think of that.
Yeah.
Certainly, we'll think of that, sir. And
Think
thank you,
of-
sir. Sai Teja, Shanti Mantra.
Yeah.
Yes, yes.
Om.
Shanti, Shanti, Shanti. Samastaloka Sukhino Bhavantu. Samastaloka Sukhino Bhavantu. Samastaloka Sukhino Bhavantu. Om Shanti, Shanti, Shanti. Jai बोलो भगवान श्री सत्य साई बाबा जी की जय।
जय श्री साई राम।
Sairam to all of you.
Thank you, Sarah.
Sairam, sir. Sairam, everybody.
Sairam, sir. Sairam.
Sai Ram, sir. Sai Ram, everybody.
Sarah, sir.